So Janta, this is one of the whiteboard question that is normally asked in programming interview questions. Okay, the question goes something like given an array of single digit numbers, check if numbers 1, 2 and 3 occurs consecutively in any order. Okay. Return the location if they do, otherwise return minus 1. So for example, if given array is something like this, here we can see that 1, 2, 3 occurs at the beginning of the array. So this program should return 0. Okay, in this example, we see that 1, 2, 3 occurs, but not in the order of 1, 2, 3, but in some other order, but still it exists and it exists at the location 3, 0, 1, 2, 3, so it should return 3. And in this case, 1, 2, 3 do not occur in any order, so this should return minus 1. So this is the program that is asked. Okay. So let's see how the nav approach will look like. Okay, so this is written in JS JavaScript. This is a JS code. Okay, so we have named the function as LOC. We are taking array as an input within the variable ARR. So we are simply looping from I equal to 0 to I less than n minus 2. Okay, n minus 2 because we are accessing the next two elements, so we do not want to over index the array. Okay, we are assigning the variables x, y, z. Okay, so the current element is x, the next element is y, and next to next element is z. Okay, so at that time we are looking at the next three current element and the next two elements, and then this is the condition that we are checking, that if the current element is 1, the next element 2, and the next to next element 3, or the current element is 1, the next element 3, and the next to next element 2. Okay, so this is just one condition, and similarly we are repeating this condition if the current element is 2 and the current element is 3. Okay, so and if this condition matches, then we are returning the current location, which is I. Otherwise, if it comes out of the loop, we are simply returning minus 1. So once the loop exited, we know that there do not exist such element or such a sequence of 1, 2, 3, and we are simply returning minus 1. Okay, so this approach will work, this program will work, but there are some issues or some problems with this approach. What are those problems? So the first is that there are too many conditions. Okay, so if you try to uh, test all these conditions, you will basically need all the combinations of 1, 2, 3 to be tested. Okay, and this is not good for the code coverage. Having so many conditions will increase the psychometric complexity of your program, and this is not good for your overall program. Okay, and the other thing is that it's not easily modifiable. So if I tell you to change 1, 2, 3 to 4, 5, 6, you will have to by hand change all the 1 to 4 or all the 2 to 5, and likewise, and then there is a good chance of getting any human error there. Okay, so this approach though work, this is not the best approach that we can say, and can we think about some better approach than this? Okay, so think about the better approach. We'll need to avoid the long condition, and to avoid the long condition we will need a function. Okay, a function which will take the three arguments. Okay, and then it will just simply output a single number, and the nature of this function should be such that the output should be unique and the function should be commutative. Okay, so what do you mean by that? So output is unique clearly if you are inputting three numbers like 1, 2, 3, the output of this number should not be same as inputting 1, 1, 3 or inputting 1, 4, 1, 4, 3. Okay, so output of all these input should be different, and by commutative is simple, that in any order if you run the function it should work. Okay, so let's see if we can find out some function. So let's say addition. So function of ABC is equal to A plus B plus C. So function of, but we see that even though this is commutative, because we know that addition is commutative, but function of 1, 2, 3 is 1 plus 2 plus 3 is equal to 6, which is same as function of 1, 1, 4, which is again, if you add 1, 1 and 4, it will give 6. So this is not unique. Okay, so this is not the function. Addition is not going to suffice our purpose. Then again, of course, if we are adding the 0, then this is anyway going to even more problems, because now you have more multiple inputs which are giving you the same output. So addition will not work. Let's see multiplication. If multiplication works, so function of a b c is equal to a into b into c. Even though this is again commutative, this is not unique, because we see that function of 1 2 3, which will give you 6, is same as function of 1 1 6. This will also give you 6. Okay. So does there exist some function? And yes, there exists some function which is simply function of a b c is equal to 10 raised to a plus 10 raised to b plus 10 raised to c. Okay. This has simply came from our number system, the way our number system works, okay, with base 10. So with this, our function of 1 2 3 will give you 10 raised to 1 plus 10 raised to 2 plus 10 raised to 3, which is 1110. Okay, so 10 raised to 3 is 1000, 10 raised to 2 is 100, and 10 raised to 1 is 10. So this will simply give you 1110. So this is the magic number that we will use in the program, and this is how then the program will look with this new approach. So we are still doing the same thing. We are assigning x, y, z as earlier, but instead of that long condition, now we have reduced it to this condition, which is math.pow 10x plus math.pow 10y plus math.pow 10z. So math.pow or POW is a power function in JavaScript. Okay. And we are adding all this, and then we are checking whether it is giving you us the magic number, that is 1110, 1110. If this condition is satisfied, we are returning this location. So basically we are saying that yes, at this location 1 2 or 3 exist in some order, and then again if we are not finding any such location, we are returning -1. Okay, so this will work. Okay, this will work, but then again this may not be necessarily the optimized solution. There are some problems with that. Okay, let's see. So first is the power function. Okay, so the power function is not necessary in all languages come with your standard libraries. Okay, so you may have to add some extra libraries or import some extra libraries to get the power function, or worst to worst case you have to write your own power function, which is not that difficult, but still you will need power function. The other thing is that this may go into the overflow, because 10 raised to 9 is a number which may not come into 2 raised to 32, or 10 raised to 9 plus 10 raised to 8 if you do, it may overflow. And so you have to be really careful with the data types that you are using. So in JavaScript, everything is variable, but in some statically typed language like C and Java, you will have to carefully choose your data type. So overflow may occur. So what can we do to avoid this? Okay, so the simple approach is that instead of base 10, we can use the base 2. Okay, and it will work. Okay, it will work. So function of a b c is equal to 2 raised to a plus 2 raised to b plus 2 raised to c. So instead of 10, we are using now 2 as a base. So what then? So are we simply replacing in our program mat.power 10x with mat.power 2x? No, because 2 raised to a is same as 1 left shifted by a digit. How does this work? So 2 raised to 3 is equal to 8, and 1 if left shifted by 3 is 1000 in base 2, which is 8. Okay. So if you know, the more you take 1 to your left side, you are simply multiplying by 2, or in the other words, you are simply increasing its power. Okay, so if you are shifting 1 by 1, you are getting 2, because this is 2 raised to 1. You are shifting 1 by 2 position, you are getting 2 raised to 2, which is 4. Okay, so on. So this function will work, and shift-wise operator will work. So the advantage of left shift operator is that it comes by default in most of the programming languages. You don't need any extra libraries for that. It is fast, much compared to your POV function. This operation left shift happens at the hardware level. Okay, and then 2 raised to 9 is 512. So maximum you are going to deal with 1024 number, and so there is very less chance of, I mean absolutely no chance of any overflow occurring. Okay, so with this, how our program will look. So now our function is function abc equal to 2 raised to a plus 2 raised to b plus 2 raised to c, and function of 1 to 3 is 2 raised to 1 plus 2 raised to 2 plus 2 raised to 3, which is 14. So 14 is our magic number, and when you use this in program, so we have changed the program name now to location of bitwise, and we are doing the same thing, except that the condition is changed. So we are 1 left shifting by x plus 1 left shifting by y plus 1 left shifting by z. If this is equal to 14, then we are returning that location. Otherwise, if entire array has been processed, we are returning minus 1. So this is the final program, and this is how you should approach